Now, another thing is, I know you and I love to teach about river systems and helping the students to understand that, you know, what is the connectivity? What's the shape of the drainage? Why should we care about river systems, et cetera? One of my favorite introductory layers in that is what's called the Esri World Hydro Layer. And it comes from a compilation of scalable river systems information from different mapping organizations around the world, including the USGS here in the USA, Natural Resources Canada, the Ordnance Survey in Great Britain, et cetera. But this Esri World Hydro Overlay gives you a sense of, okay, once I bring this data into something called ArcGIS Online, I've got the capability that Joseph keeps talking about, adding data, changing the symbology, adding, changing the scale, et cetera. So here I've got this set of layers. So I've got a layers tool on the left side, okay, and I've got Esri World Hydro Reference Overlay. If I zoom in there, it's going to give me this sort of scaling effect that you see in a lot of different mapping tools nowadays, including Google Maps, right? As you zoom in, you get finer and finer resolution. And so same thing here at the global level. And let's say I was teaching, you know, third grade. I want to look at major rivers of the world. So I can see the Yangtze, I can see the Lena River, I can see the Mississippi, Missouri system here in the USA. And I can see sort of the width indicates how much volume those rivers have. So the Columbia River, et cetera. But as I zoom in a bit more, I'm seeing more tributaries. And as I zoom in a little bit more than that, and you can see where this is actually could be a nice 20-minute lesson or a half-hour lesson or a one class period lesson about river systems. And getting the students to understand, for example, that rivers flow away from Colorado, and why is that important? But as I zoom into, let's say, our own state, I know many of you are from Colorado, I've got this sort of nice scale right here where I've got all of Colorado in this one frame. Those dotted lines, they're the watersheds, right? So I've got, oh, the Platte River, the Arkansas, the Rio Grande, and the Colorado watersheds. But as I go in further, I'm going to see the sub-watersheds here. Okay, and getting the students to understand the relationship between watersheds and terrain, and again, why that matters. Okay, so we could even use this in conjunction with our Las Vegas example earlier. So now as I zoom in, I'm going to see, oh, okay, the St. Vrain watershed versus Clear Creek versus the South Platte, et cetera. You see these sub-watershed boundaries in here now. Wow, this is fascinating. So just with this one tool, I've got a lot at my fingertips. And this is the World Hydro Reference Overlay. And there's other data that you can tie to teaching about river systems, the slope, the elevation, the aspect, the direction of slope. I've got some links in there that unfortunately we don't have time to get into right now. But why does the direction of slope matter? Water retention, getting the students to think about something that they've experienced. Why do most ski areas in North America, in the Northern Hemisphere, why are they mostly on the north-facing slope? Again, angle of the sun, lots of spatial thinking you can teach in there. National inventory, where are the dams located? Why are they located where they are? What's the future of holding back water? Oh my gosh, okay. Now, another thing that gets us all excited, right, is that we can actually use real-time information. So for example, here in the real-time zone, section 5 here, one of the things I have is, and I'm not going to show this just because I want to keep be sensitive to all of your time today, but this is just a screenshot of, think about this as an interactive map, and as I click on the different stream gauges, I'm going to see, in this particular one, it's a little blurry, but you can see that the floods are symbolized in this fuzzy sort of symbol. So you've got this greenish for floods, and I clicked on this one in Arkansas just about an hour ago, and or 2 hours ago, and you can see this is in flood stage, so it's got this symbology. What about the ones in Colorado? So it's interesting to go through the year, and of course in May, hopefully we'll get some decent, runoff and some more decent snow between now and then, right? Fingers crossed. But looking at, okay, what's the condition of the Middle St. Vrain or the Colorado River or the Eagle River, et cetera. And you've got this interactive tying to my old organization, USGS, the real-time stream flow information. But this also is a global data set. So you can look at the Yangtze, the Lena, the Nile, et cetera, with this same set of tools. I wish I could get excited about this. Anyway, this is so cool that it's so useful because you've got, as I've got in this link, okay, what's the relationship of stream gauge and what is a stream gauge? And clicking the Boulder Creek, the Middle St. Vrain, the South Platte, and on down the Platte, the gauges, right, the CFS, the volume, gets higher. If your hypothesis is as we go toward the mouth of the Mississippi River, the volume is going to get higher. Yeah, you can talk about diversion for agriculture in cities and so on, but generally those volumes get higher. And even show them a picture of, hey, what's the size of the Mississippi at St. Louis versus the Mississippi up at, middle of Minnesota, okay? So, but tying to this, you've got the volume, you've got the flood stage versus non-flood stage, and then you can also, as I'm clicking on here, but I'm not going to show it right now, but real-time weather. So, okay, if there's a big rain event, my hypothesis is that that river is going to increase over the next 48 hours, say, and then check back tomorrow. Did it confirm your hypothesis? All with these same interactive mapping tools. Now, we're not just focused on land-based water, right? Reservoirs, streams, rivers, springs, dams, and reservoirs, etc. But one of my favorite tools is something called the Ecological Marine Unit Explorer. So getting the students to think about, the oceans are dynamic as well. It's not just this expansive blue or green that we see on most maps. That actually has variability. And our chief scientist at Esri, Dr. Dawn Wright, she is an oceanographer, geographer. And she and other scientists got together from multiple organizations to create a variety of tools, including the Ecological Marine Unit Explorer. And this gives you a 10-kilometer spacing of data. Again, look at the metadata, find out how they derived all of these points. But you've got here, I click on offshore of California, let's say, and I've got, on the right side, if this is part of your environmental ed, okay, there's some, what is salinity, right? What is temperature, what's dissolved oxygen, et cetera. So there's some background, sure, so that students understand what these variables are. But being able to go to profile and see the temperature at that spot on down to the floor from the surface, I think is really powerful. Okay, bring it back to their own experience. Who has swam in the Atlantic Ocean off of North Carolina or Florida versus the Pacific? Which is colder? Okay, well now we're looking and we see right here that, the Atlantic is warmer off the coast of the continental United States anyway. Why? Well, okay, let's look at world ocean currents. Again, ArcGIS Online, you've got interactive capability, you can change the symbology, you can change the scale, etc. But inside here, we've got these world ocean currents, and there's the Ecological Marine Units Explorer. I'm going to close that for the moment, but let's close this one as well and open up the world ocean currents in a new tab. Okay, so now we've got the metadata. I kind of breezed by this a couple times, but I wanted to let you know that every page, every map has a set of data like this. It may be a little boring to look at sometimes. Sometimes there's not very many graphics, but you've got where did this come from and why was it created? So here I've got this metadata for this layer, and I say, I want to view it in this arcgis.com map. So as I do that, again, nothing against textbooks, and Brianna very graciously mentioned that I've written several of them myself, but the folks, I want to emphasize that you're not stuck with, this map on page 300 of your textbook. Again, nothing against those resources, that they have their place. But you've got here, I've got a lot of other data at my fingertips here that are interesting too, but in this particular case, I'm going to turn off some of these other layers, but the point is, what I wanted to focus on is, we've got it in ArcGIS Online now, and I'm going to look at major ocean currents, and I'm going to look at a couple of these other things. Now I'm going to zoom out, and I've just turned off a couple layers, that's all. And now I've got, okay, I've got this now. Okay, I've got this sort of thing, right? And I've got a base map. One of the base maps is oceans. Okay, I kind of like that a little bit better. So the point is, I've got a lot of capability at my fingertips, and the other layers that I'm turning off are climate layers. So again, you're not just looking at these layers in isolation, like, okay, given what you know here, and what we've talked about yesterday in class, right, students, about the Gulf Stream, you've got this northerly influence of warmer water in Europe, so you're going to have other things that you can look at, climate, biomes, and so on and so forth. Where's permafrost in Europe versus Canada? Okay, we can see right away. That's what's powerful about maps. In one glance, or with a few investigations, you've got a lot of inquiry going on. Maps have always been very useful. A lot of information in a short amount of space. especially now that you've got these in digital forms at your fingertips. So I wanted to introduce that and make sure you knew that that was available. Ever so briefly, in our sort of closing 8 minutes-ish, 7 minutes-ish, I've got a couple of things to cover, and then we're going to have some discussion and questions. I wanted to indicate a confirmation of what I talked about at the beginning of the webinars, that we've been consuming data from a variety of different organizations so far in this webinar. The imagery comes from a variety of private companies, Maxar, which is located right here in Colorado, used to be Digital Globe, along with the USGS, Natural Resources Conservation Service, and others. We've used data from federal, international, local agencies, and so on, mapping and science agencies. But also remember that you can actually collect data yourself, along with your students, map it, analyze it, and tell a story about it. So I'm just going to select one of the projects that I've been involved with educators over the last year and a half or so, and that is something called the Data Citizens Project. So one of the focuses of the Data Citizens Project was to get students interested in watersheds. And one of the things, what could we easily collect data on? You know how many constraints there are in getting students out in the field, right, folks? You know that as well as I do. But one of the things that I wanted to just mention is that they thought, okay, these are Western New York, so social studies, science students, Buffalo area, and others. They decided, let's collect data on storm drains. First of all, they're easy to collect. They are often overlooked. Like, why do we care about storm drains? What does that have to do with the environment? Turns out a lot to do with the environment. But one of the things that the students created and the educators created here was, we're going to collect data on storm drains. Okay, that's easy to find, and there's some in our own community, so we don't have to bus students to the nearest, river system and analyze data there. Nothing wrong with that either. But then what they did was after they mapped these things, you'll see a lot of them in Western New York, because this is actually where the project was located. These other points are ones that I've added here in Colorado and other educators added. But the point is, they've got some data that they've collected here in Buffalo. And what they did was, you can see that, oh, okay, there's a typical storm drain. What is this thing that I'm showing right here? It's a dashboard. And so the project leaders, the educators, people like you, K-12 educators, they created this dashboard. And in the dashboard is a couple of things. First, it's the results of their field investigation. So they use something called Survey 123, and just like SurveyMonkey or Google Forms or other survey tools that you've used, the advantage of Survey 123 is that it's drag and drop, true, false, multiple choice, Likert scale. But the thing that makes it a little bit more aligned with analysis is that it maps the results right away. And from that results, you can actually create what's called a dashboard. Now, everybody on the planet with a device has seen the JHU COVID dashboard. That was created with the same tools as I'm showing right now, created by Johns Hopkins. Why was that so popular? Why is it so popular? Because it's very useful. In this case, just like the name implies, a dashboard gives you and the project people a sense of, okay, so far, the students and the instructors have collected 81 storm drains. And this is who collected them. This is a little bit of, here's a geeky video of me talking about the importance of storm drains, but more importantly, it's all shown in this dashboard. We can look at the different points that were collected and notice the base map that we've got on here. The base map has the World Hydro base map that we talked about earlier with the watershed boundaries and the rivers. And the left side here is real-time weather, like I talked about earlier, where you've got, okay, wind speed, wind direction, precipitation, etc. 421, gosh, that sounds kind of familiar. Oh, that's today. Okay, you got a real-time data feed. So these tools are powerful and they're accessible. And again, these educators here, they're just like you. They weren't GIS gurus, but creating a dashboard like this is basically like the following. Without any coding, you say, I want a pie chart over here, I want an image over here, I want the map over here, and you're just dragging and dropping like jigsaw pieces on a board is what you're doing. And there are plenty of tutorials to help you do that, but that's basically how you do it. So don't forget about the you can collect data yourself component of all this.